So I was discussing that in case of traditional regression, you may have some of the model fit indices like model fitness using the sig value. You may have the f value. You may have the r square value. But in case of SEM, you may have some detailed values related to the model fit indices, and I will specify these values as well as our learning progress, and we move forwards towards the much more deeper detail about the model fit indices. So there is another difference you can see in the next slide. This is basically the direct and indirect effects. In case of traditional regression, it estimate the direct effect between dependent and independent variable. Although using the process by Hayes, we can also estimate the indirect effect, but that is an additional tool which is included in SPSS. But SPSS was not mean to estimate the direct effect. It is the additional tool like Hayes process that assist the SPSS in estimating the direct and indirect effects. SPSS was mean to consider, or the regression tool was mean to consider the direct effect only. In case of SEM, it allows both direct and indirect effect, providing a more comprehensive understanding of the relationship in the model. Then hypothesis testing. In case of you can say the regression analysis, we may need to test the hypothesis on individual parameter level. So parameter means beta or coefficient. So when you need to test your individual coefficient of your individual dependent variable as a relationship with the independent variable, you are dealing with the traditional regression. But the SEM allows the multiple hypotheses simultaneously within a single model. Sometimes we may have an independent variable which is impacting the dependent variable, but along with that independent variable, we may have some dimensions that are also individually impacting the dependent variable. In that case, we may have a simultaneous hypothesis dealing with that model. SEM allows multiple hypotheses simultaneously, while in traditional regression, we are dealing with the single hypothesis of every single parameters or beta estimate. Then we have two approaches of SEM that we need to know. Today, I am going to discuss the first one approach, which is PLS-SEM approach, and tomorrow I will be discussing about CB-SEM. So these are very renowned approaches that you can use. CB-SEM, structural equation modeling, that is covariance based structural equation modeling, and that the second one is PLSM, which is partial least square structural equation modeling. These are the two major approaches within the broader field of SEM. Both methods are used to analyze relationship among variables, but they have some differences in terms of their underlying principle and application. You need to know the difference when to use the CB-SEM method and when to use the PLSM method. And one thing I would like to let you know that using the smart PLS4, you can apply the CBSEM as well as PLSM. But in case if you are using the SPSS MS, which is the sister software of SPSS, you can only use the CBSEM method. But in case of smart PLS, you can apply both approaches like PLSM and CBSEM. So what is the difference between CBSEM and PLSM? You need to have an idea that CBSEM is an approach in SEM modeling that focus on estimating the relationship between observed and latent variable by maximizing the fit. You can maximize the fit between observed and estimate covariance matrix. It is based on the assumption of multivariate normality. So if your data is normal, it means you may have number of observation greater than 30, or your sample size is greater than 30. It means your data is normal. You have multivariate in your variables. You can apply the CBSEM, because it basically supports the data with large sample or a normal sample, or the data with normality assumption is, you can say that normality is meet, or normality assumption is fulfilled. So it employs method like maximum likelihood or weighted least square for parameter estimation. So what are the key points when you need to apply the CBSEM? It assumes multivariate normality. It means your number of observation should be greater than 30. Your sample should be greater than 30 observation. Your data should be normal. Second thing, it is suitable for large sample size. It emphasizes testing model fit and parameter estimate. And one thing that I would like to add over here, CBSEM basically is useful when you have some theory in order to test the relationship between your independent and dependent variable. But if you do not have a supporting theory behind, or the theory is need to be extended, or need to be you can say advanced, or you need to be added some you can say new findings, then you may apply the PLSM. In case of PLSM, it is basically the reverse of CBSM. PLSM does not assume multivariate normality. It means if you have less than 30 observation in your data set, your data set having the smaller sample size, and you want to predict the relationship between the variables, it means you need to use the PLSM. So if you do not have some theory in the background that need to test the relationship between independent and dependent variable, or you have a theory but that need to be developed, or that need to be advanced, or that need to be extended using the current relationship, or your priorities basically the prediction actually, then you may preferably use the PLSM. But basic consideration is basically the sample size. If you have a sample size which is less than 30 observation, a smaller sample size like 10 observation, 20 observation, 25 observation, because some of the study may require a data set which is possible to collect from a very limited number of respondents, then you may perceive towards the PLSM technique. So PLSM is a non-parametric approach in structural equation modeling that aims to maximize the explained variance in the dependent variable. It is particularly suitable for model with latent variable many latent variable and small sample sizes. So PLSM uses partial least square method for parameter estimation. So in case of CBSEM, you are going to use maximum likelihood method or weighted least square method. But in case of PLSM, you are going to use the partial least square method because it basically assists in minimizing the error using the partial least square method, and it does not rely on normality assumption. So this is basically the difference. I think you have understand the difference between both concepts. So what is the next thing? There are some terminologies in the SEM that you need to understand because most of you may be new towards the SEM. So before analyzing any deeper detail or any software consideration, you need to understand some terminologies that will be useful in understanding the application of Smart PLS4. So what are those terminologies, and how can we understand the different terminologies? The first one and the important one is construct or latent variable. So what do we mean by construct or latent variable in SEM? A construct is an abstract concept or theoretical idea that is not directly observable. It represent an underlying attribute or characteristic that is inferred from a set of related observed variable. Constructs are often the focus of research in the fields such as psychology, sociology, and economics, and other related field also. So you may say, when a variable is not directly measurable, or it is measurable through indicators, or it is measurable through some statements, or through observed variables, it is considered as construct or latent variable. You can say this picture I have shared. In order to measure the usability as a construct, you need to measure the efficiency, learnability, and memorability. And in order to in order to measure the learnability, you need to measure user self-report, average number of error across trials, and number of trials needed to reach 80% task completion. So usability, you can say, is a construct, because it cannot be directly measured. It can be measured through three dimensions, and these three dimensions are further measured by some indicators. So a construct is the variable of your interest that you want to measure through indicators. So here, in this picture, you can also see like quality of T and K transfer. It is measured using the 5-point Likert scale through these indicators: one, two, three, four. Like congestion of firm, it is measured by these indicators: quantity of FDI divided by MNC, quantity of local firms. So how you are measuring? You cannot measure the quality of T and K transferred directly. You need some indicators to measure it. So when a variable is indirectly measured by some indicators, it is called the construct or latent variable. So you need to see this picture. Then coming to the next part, what is observed variable, or indicator, or manifest variable? So it is a variable that is directly measured. You can say, if a variable is directly measured or already observed, these are tangible and concrete. These are used to quantify the latent constructs and are typically used in the measurement model. Example of observed variable for the self-esteem: latent variable may include item from self-esteem questionnaire, such as I feel confident in my ability. This is basically the statement which is measured by a 5-point Likert scale. So we can say observed variable is the statement or the indicator or the fact. Again, there was a little interruption in the internet, but I have connected again. So I was letting you know that what is observed variable. It is directly measured through some statement, some questions using 5-point Likert scale, 7-point Likert scale, or any scale which is provided with your questionnaire. So how can we understand more broadly this concept? For example, you may have you want to measure a concept or a construct, the name of which is self-esteem, and you want to measure it through a number of factors like this: SE1, SE2, SE3, SE4, SE5, SE6, SE7, SE8, and SE9. Here self-esteem is basically a construct or unobserved construct because it cannot be directly measured. However, SE1, SE2, SE3, SE4, SE5 up to SE9, they are basically the observed variable because these factor or these indicators indicate the statement which are measured directly. So in order to measure the self-esteem, we need to measure these statements. So how can we identify in a questionnaire? If you see the following graph, in order to measure the self-esteem, we need to measure the indicators like overall I am satisfied with myself, I feel that I have several good qualities, I can do something the way most people do. So these are the statements which are also called observed variable. They are also called the indicators, they are also called the factors. So in order to measure the self-esteem, we need to measure these statements. So that is the difference between a construct and an observed variable. You can say self-esteem is unobserved because it cannot be directly observed without including these statements. So that is the difference between observed variable and construct. So what is the next thing? Next thing is endogenous variable and exogenous variable. A variable or construct or latent variable that is influenced by the other variable within the model. Endogenous variable are basically the dependent variable. In a regression analysis, when we consider a variable as a dependent variable in SEM, when we are considering the SEM, we may replace the name with endogenous variable. So endogenous variable is basically your dependent variable, while exogenous variable is basically your independent variable. So a variable that is not influenced by the other variable within the model. So this is a good idea to understand, like if I would like to measure the academic performance as a construct, and it is basically measured by these six indicators or these six factors or these six you can say observed variables. And I would like to measure the self-esteem using these nine indicators. So if